Next topic is going to look at a past paper question for area and perimeter. Now this tends to be a non-calculator question, but you can basically guarantee it's going to come up. There are sometimes easy ones, just like a normal rectangle, but tends to be compound shapes, so like two rectangles put together like the one below. So we're going to have a look at finding the perimeter and the area for these. Now the first thing you have to know is what perimeter is and what area is. Perimeter is the distance around the outside of a shape, so just imagine you're walking around the shape. Area is the space inside the shape. Okay, so two different things, and they actually have different measures, which are really important, which we're going to have a look at after. Now the perimeter, what I always do, you obviously read the question, overlapping rectangles. Each rectangle is a 9x3, and they're placed so as to make an L shape in the diagram. What I always do, for perimeter, I have to know every single measurement. So I start by filling in the missing ones. Now you can see that two of the sides, the sort of inside parts of the L, are missing. Now, I can't find the perimeter unless I work out what them sides are, okay? So that's the first thing. Now, to work them out, what we're going to do, we're going to think about it across, and then we're going to think about it up to down, okay? So I'll show you what I mean by that. Right, long side there is 9. The little short side across from it, running the same way, running vertically, is 3. Now, I've also highlighted the missing side I want to find in yellow. Now, imagine the blue side being pushed in until it was perfectly underneath that yellow one. And you could then see that the blue plus the yellow one, if you put them on top of each other, would have to equal the other colour on the left-hand side. Okay, so the blue plus the yellow has to equal the one on the left-hand side. So if the small little one is 3, and I have to get to 9, well, obviously, the yellow one has to be 6. So what I'm going to do is I'm going to go on, and I'm going to label that side 6 centimetres. Now I'm going to do the same with the other missing part. This time I'm going to think about it up to down. So again, blue one is 9. Darker blue one, sorry, at the top. That's 3, and then I've highlighted the missing one that I want to find in yellow. Imagine the blue one being squeezed down until it's perfectly in line with the one that goes across in yellow. You could see then that the blue one plus the yellow one would have to equal the fluorescent blue one below it. So if the little one is 3 across the top, has to be 9 in total, then the yellow one again has to be 6 centimetres. Now you get 1 mark straight away for telling the examiner what them two missing sides are. Now the perimeter is pretty straightforward from here. All you're going to have to do is add up every single measurement you've got on there, okay? You never go inside the shape, it's just from the outside. So imagine I started at that blue point and I'm going to walk around that direction until I get basically back to my green point at the top. Now, write down all your workings because it is worth a mark if you go wrong. So basically 3 plus 6 plus 6 plus 3 plus 9 plus 9, and then back to the start. That's worth your second mark. Your first mark would be the missing bits. Add them up, 36, and it's centimetres. It's centimetres because it's a distance, okay? That would be your other mark. Area then. Area, like we said before, is the space inside. So I don't know the formula for finding the area of an L shape, but I do know the formula for finding the area of a rectangle. And if you look at the question, it says that it's basically two rectangles being put together. So I'm going to use what I know about the area of a rectangle, which is length times width, to find the total area of that shape. Now you can split this up into either 2 rectangles, like I'm going to show you, or you could actually do 3 rectangles, okay? Well, 2 rectangles, and then the one in the bottom left would be actually a square, okay? So you could split it up like that as well, but I'm going to do 2 rectangles. Right, there's my first one in red, and then my second one in blue, and I'll shade them here. Okay, so I'm going to call that one A and that one B. I'm going to find the area of A, pretending B isn't there, and then the area of B, pretending A isn't there, and then I'm basically going to combine them to see the total area. The area of A, right, it's a rectangle, so in my head it's length times width. I know that about rectangles. Right, the length is 9 across the bottom. You completely disregard the blue one at the moment, is 9, and the width is 3. So 9 times 3 equals 27. Okay, nice and easy. B now, pretend the red one isn't there. We've dealt with that, completely disregard that. B, it's a rectangle again, so it's length times width. Now, the length this time is the 3 across the top, and the width is not 9, it's 6, okay? Because 9 would be the total for both parts of the rectangle. I only want down as far as the blue bit, so I only want the 6. So this one's going to be 3 times 6 equals 18, okay? If you want to do it the other way round, so 3 times 9, 6 times 3, you're thinking about length and width the other way round to what I am, that's absolutely fine, okay? It doesn't really matter as long as you multiply them together. Now, to get the total area, I know what A is and I know what B is. I'm going to have to add them together. So total area equals 27 plus 18. Add them together and you're going to get 45. This next part is really, really important. If you don't have a clue about how to find the area of a shape, if you write this bit down, you will automatically get 1 mark, okay? So you can pick up a mark here even if you don't know what you're doing. It has to be, it's a space, so centimetres squared, okay? So that part there, that 45 centimetres squared, I've put a 2 next to it because it's worth 2 marks. You're getting 1 mark for the 45 and 1 mark for the centimetre squared. Okay, so you can still get that centimetre squared mark regardless of what's in front of it, okay? You'd also then pick up marks higher up for the 27 and the 18 and so on. If you did go down the other route, like I said before, you did 2 rectangles and 1 square, what you'd actually get, you'd get 18, and then the square would be worth 9. You'd add them together, you'd still get 45 centimetres squared, okay? So it doesn't really matter what method you follow, as long as you're doing length times width and you pick in the correct measurements for each rectangle.